So irrational numbers are numbers that will either stop, terminate, or they're going to go on forever, but in a pattern. So some examples are 15, 0, negative 2/3. The square root of 36 is rational because that equals 6. A negative square root of 49 is rational because it equals 7. Anytime you see a line over a number like this, that means it's repeating. So this is really 5.78787878, and it goes on forever. All of these rational numbers can be turned into a fraction. The last one here, 0.14, that's also rational because it's the same number and it's repeating over and over again. Specifically, this would be turned into 14/99. That's the fraction. If a number can be written as a fraction with an integer on the top and an integer on the bottom, it's rational. Irrational numbers are numbers that are going to go on forever without any kind of pattern. So the pi is a famous one because pi is not 3.14. It's a number that goes on forever. The square root of 2 is also rational. Put it in your calculator. You're going to see it does kind of stop somewhere, but that's because your calculator runs out of room. And it's not any kind of pattern to it. And the last one, even though there's a pattern to it, it's not repeating itself over and over and over again. So that it's going 1, 3, and then 1, 3, 3, 3, and then 1, 3, 3, 3. There's 33s, and then 1, 3, 3, 3, 3. And you could take an educated guess that the next few numbers there would be 1, 3, 3, 5 threes there, and it would keep on going. But that's irrational because we can't turn that into a fraction. So is 0.856556555 rational or irrational? Well, it's irrational because it is going on forever, but it's not in a pattern when it's repeating itself over and over again. Which of these numbers are rational? That means that either it stops somewhere, or if it goes on forever, it has a pattern to it. So 9 is rational because that terminates. That could obviously be turned into a fraction. Pi is irrational, so we'll leave that alone. Negative 5 is rational. 8/3 is also rational. 0 is rational. 3.45 with the line over it, that's rational. And then 13/2, that's also rational because it's in a fraction. So the only one there that was actually not rational would have been pi. The last one here, the number is 1.444, going on forever. That's what the little 3 dots mean. And 1.555 are both rational numbers because they're both going on forever. So we're going to find which of the following is an irrational number that is between these two numbers. And this could be a great essay question. The first one is irrational, but it's 2.445444, which is not in between 1.444 and 1.555. So that one's not. 1.554555, that's irrational because it's this type right here. It's not repeating itself. And that would fit in between those two numbers, so that would be 1. And 1.445, that's rational because it terminates, so we'll cross that one out. And then finally 1.445444. This is also irrational because it is going on forever and it's not in a pattern where it's repeating itself over and over and over again. The same digits, the same amount of times. If you have any kind of questions, please ask your math teacher.